importance of this particular topic in that is functions. Why we have to learn functions? Because at the end of the chapter we talk about inverse functions, and when it comes to inverse functions, that is very important for us to understand the second chapter, which is inverse trigonometric function. Okay, so we have learned trigonometry basics in the first year, that is 11th standard. Now we're going to discuss about inverse trigonometric functions. Apart from this, what is the importance of this topic is, if you are writing any competitive exams, let it be any local bank exams or any government exams, maybe GRE, GMAT, or UCAT, or if you're writing SAT, anyway, we talk about functions. Okay, so this is a very important topic, not just for the matter of 11th, 12th grade board exam, not only for that, for any other competitive exams, even JEE, if you're writing, we get a lot of questions related to relations and functions. Okay, so yes, let's anyway focus on only our CBSE board exam right now, but just giving the significance of this particular topic. Okay, so first, what is a relation? Let's talk about relation. What is a relation? Let me present this. Yes. If there is any clarity issue in the screen, you can even tell me. Okay. So what is a relation? Before entering to this relation part, let me talk about what we learned in the first 11th standard, which is sets. We discussed sets, and then we discussed product of two sets. Do you remember this? Cartesian product of two sets. For example, if a set has some elements like 1 and 2, and another set B which has another set of elements A, B, C, what is A cross B? Can you recall it? So A has how many elements here? 2 elements. B has how many elements? 3 elements. And A cross B will have how many elements? Definitely 6 elements. That is a product of the number of elements of two sets, right? So can you tell me what are the ordered pace we get here? This is how you write the product. So 1 is multiplied with each element. I mean, we are pairing with each element in the next set, right? 1 comma C. These are 3 elements related to 1. Now we have 2 comma A, 2 comma B, and 2 comma C. Can you see this? Yes. So this is A cross B, right? This is a product of A cross B. Now, what is the relation? If you take any one element from this ordered pace, and each and every combination of the elements you take, that becomes relation. Okay, so in general sense, in English, what is relation? If there is a connection or a link between two elements, or maybe two persons, for example, if A and B are siblings, what can be the relation between them? Possible relation: A can be a brother, because I mentioned sibling, or A can be sister, right? And another example, maybe if A and B are family members, that is a relation. So what is the possible relationship between them? They can be mother, A can be mother of B, A can be father of B, or A can be son of B, daughter of B. There are many relations, right? Similarly, in mathematics, we established relation between any element. Suppose if there is no relation at all, that is also one of the relation. Okay, that is no relation. Okay, that is what relation is all about. Now, in this product of A and B, what we are talking is, if I take any subset of this product, that becomes a relation. Okay, so it is mentioned here in general sense. A relation means a link or connection between two objects or quantities. Okay, so two objects should have one common thing. But I mentioned if there is no common thing, that is also called as a relation. Okay, so in mathematical terms, how to define relation is, if A and B are two non-empty sets, then any subset R of A cross B. I just now mentioned, right? If you take anything, if you take just 1 comma A from this, that is a subset of this A cross B, right? This is one relation. If we take all of them, that is another relation. If you take any 2 of them, or 3 of them, 4 of them, everything becomes a subset of this product, right? So that is nothing but subset. That is, a relation is nothing but subset of product of A cross B. Hope this is clear. I am erasing this. Yes. So a relation from A to B implies what? Double implication relation that R is a subset of A cross B. Okay, you can say, see the arrow mark here, double implication. This means this and this means this. So both are double implicated to each other. Okay, right. So now there is an example already. There is a set A 1, 2, set B 3, 4. What is A cross B? A cross B. Set A has how many elements now? N of A has 2 elements. N of B has 2 elements. So A cross B will have how much now? 4 elements. Yes. See, all these are very important because you may end up not understanding the question if you don't know these basics. So N of A cross B will have how many elements? 4 elements. Okay. Now they took one subset and they're naming it as R1. So one subset which is having only 1, 3 and 2, 4. And this is actually a subset of A cross B. And remember this symbol means subset. This relation R1 is a subset of A cross B. Right? Yes. So now it is called as a relation from A to B, right? So there is an example, we can check this. Let me read the example quickly. Let us suppose teacher A is teaching English in a school and teacher B is teaching physics at the same school. Now what can be the relation between A and B, right? So A and B works in the same school. That is a relation. That's an example, right? And another example, an ordered pair A and B, which is belonging to A comma B, where the relation, how do you read this? As we know how to read the set, there are two types of set. One is roster method, another one is set builder method, right? So this is usually set builder method, where we read the bracket as first bracket, the open bracket as set of all. Okay, set of all. And A comma B is ordered pair. And when we use this semicolon, we say such that. So how to read this? I'll read this again. Set of all ordered pairs A comma B, which belongs to A cross B, such that age of A is less than age of B. That means how these A and B are related, A is younger than B. That's one of the relation. Hope this is clear. You can always reply to me in the chat if there is any issue in understanding what I'm saying. Okay. Now coming to the next example, another set of all A comma B, ordered pairs A comma B that belongs to the product A cross B, such that A is working for the same company as B. Here in general terms, I can say A is a colleague, right? Colleague of B. This is a relation, but we are anyway not talking about this kind of relations. We are getting into advanced concepts of how to understand these relations and how do we apply that in mathematics, right? Yes. Let us get into more such examples later. So now let me go to the next part of this. This is a basic relation part. So now coming to, before going to the domain part, let me explain you some important aspect of relation. So I told you if a set n of A has m number of elements, n of B, that means number of elements in B is n. We know n of A cross B is how many? M into n, right? And we know if a set A has, say, p number of elements, then how many subsets A can have? A can have how many subsets? We have learned from the previous classes, 2 power p subsets. Now, as I mentioned right now, every relation is a subset of A cross B, and A cross B has m in elements. How many relations are possible from A to B? That's a question. Can anyone guess? Yes, it is 2 power mn. So remember this, you can make a note of this. If n of A is m, that is number of elements in set A is m, and number of elements in set B is n, then how many relations are possible from A to B? It is nothing but number of subsets of product of A and B, right? And also one more thing, A cross B may not be equal to B cross A unless, tell me unless, when they are equal? A cross B may not be equal to B cross A. Suppose if they are equal, what is the possibility? The only possibility is A is equal to B. I'm just highlighting these things which might be useful for us in understanding the questions, because the questions can be twisted and you may get confused. If you know these basic things, you may not be confused, right? Yes, yes, this is what relation is all about. Okay, there is another way to represent a relation, that is by writing a mapping diagram. Let me take the same example of this set A and this set B. Here they have taken 1, 3. Set A has 1 and 2. Set B has 3 and 4. And there are many relations possible, but here in this relation R1, what we have taken is they're mapping 1 to 3 and 2 to 4, right? Right. So this is what. And what are the ordered pairs we have is 1, 3 and 2, 4. And each of these ordered pairs, if I take the first element only, what is the first element of this relation, which has only 1 and 2, right? And just remember this. I'll come to this in the next slide. So first element is nothing but what? 1, 2. That is here being used. And the second element you can see, which is 3 and 4, right? Yes. What are these? There are specific names for this. We'll discuss in the next slide, right? Yes. Yes. Now, can you see what is written here? That is domain. What is domain? Let me take the same example, or maybe let me give you another example. There are two sets. I'll just give an example for a relation which is having 5 elements here, and there are some 3 elements here. And let me define the relation. So this is a relation. Can we represent in the roster method? Yes. So 1 is related to A, right? And then 2 is also related to A, whereas 3 is related to B, as well as 3 is related to C, right? So all these are properly mentioned here. Now set of all the first elements, if I take 1, 2 and 3, this is called domain of this relation. I hope my audio is clear. You're always welcome to say in the chat if any issues are there in the audio, video, or the slide visibility. Okay. And coming to the range, what is range? What is range is nothing but the set of the second elements. And I'll add one more element here to give the difference. This is A, B, and C. But set A has, what are the elements in set A? Set A has 1, 2, 3, 4, as well as 5, right? Set B has A, B, and C. So as well as D. Yes. Now set A is not equal to this domain set, and set B is not equal to this range set. So that is very clear, which are being used. And in the relation, set of all the first elements becomes domain, and set of all the second element in the relation or in the ordered pairs becomes range. Okay, right? So now I can say the domain is always either equal to the first set or a subset of this, right? So domain is a subset of the first set. Then what is the range? The range is, okay, just, yes. The range is nothing but what? Subset of the second set, clearly, right? Yes. Let us observe this example. I'm erasing this. If set A has 1, 3, 5, 7 and set B has 2, 4, 6, 8, 10, and the relation is defined like this: 1, 8, 3, 6, 5, 2, 1, 4. Then what is the domain? You can check this as 1, 3, 5. As 1 is already repeated, I don't want to write it again. You don't have to write it. Even if you write, it should not be counted. So domain of this relation is nothing but what? Domain of this relation is 1, 3, 5. Can we talk about the range? The range is nothing but 8, 6, 2 as well as 4. Right? Any issues? Any questions here? Yes. Good to go, right? Yes. Now let's go to the next part of this relation chapter. Yes. Yeah, range, I already discussed about it. So we don't have to go through this slide. We already discussed this in the beginning itself, in the first slide itself, previous slide, right? Okay, so that is the end of the first chapter. Let us first quickly have a recap about what we learned in this first part. The first section of this chapter. What did we understood? We understood the definition of a relation. A relation is a subset of a relation from A to B, which can be written as A or B. You can write like this, a relation from A to B. So this is nothing but what? A subset of Cartesian product of A and B. Suppose if you want to relate from B to A, you need to take a Cartesian product of B cross A, because we know A cross B is not equal to B cross A. And how many relations are possible from A to B? That depends upon how many elements are there in A. If n of A is m and n of B is n, then how many relations are possible? 2 power n relations are possible from A to B, right? And what else we discussed? Yes, what else we discussed? We discussed domain of a relation. What is domain of a relation? Domain is nothing but subset of the first set which are being used in the given relation. Okay, not any subset. It has to be part of the relation, and it is nothing but what? Set of all first elements of every ordered pair, right? And what is range? Range is a subset of the second set, and it is not every subset. It is those sets which has only the second elements of the ordered pair, right? And how to denote in the set builder method is a relation is nothing but set of all ordered pairs such that A belongs to A and B belongs to B, right? We have seen all this. We are just revising these concepts, right? Okay. So that's the end of the first section, right? We will see some examples, worked out examples after getting to the next part of this chapter, right? Okay. Let me check if there is any query here. And if there is no query, we can just go forward. Okay. Yes. I have some question here. So as you don't have any question, I have some questions to you. Okay. This is the first question. So is it clearly visible? There are 3 questions I'm going to discuss about what we learned right now. So let me read the question for you. You can also read it once. Okay, I'll give you 10 seconds. If you can solve this and tell me the answer. Meanwhile, I'll read the question to you. Let R be a relation on the set n. What is n? N is set of natural numbers. N is set of natural numbers. What are natural numbers? All the counting numbers, right? This is n. And the relation R is defined like this. Can you read this? I don't have to write it again, right? It's set of all ordered pairs A comma B such that A is equal to B minus 2. That is A is equal to B minus 2. And there is a condition further, B is greater than 6. Then what is the options are there? Which are the following options are belonging to, are elements of this relation? Okay, so as the options, the question is clearly based on option, we have to check from options, right? So first option says 2 comma 4. 2 comma 4. So first let me rearrange this relation. That is b minus a is equal to 2. Is it exactly same? Yes, it is exactly same. So that means b is greater than, or you can even say b is equal to a plus 2. So b is greater than a by 2. So first option, is it working? Yes, it is working. But there is also another option, which is option C. This is also working. But do we have multiple answers for a multiple choice questions? No, right? That means there is some trap. So what is that? We are forgetting this condition b is greater than 6. Even though b is a plus 2 in the first option, it is not greater than 6. So I can rule out first option and the answer is C, right? So yes, that's our answer to the first question. Hope this is clear. Let me erase this and go to the next part. Let's go to the next question. Yes, if the question is not clear, I can just zoom it out. Is this clear to all of you now? Yes. This is something I discussed. Please read the question. I'll give you 15 seconds. I'm checking a timer here, right? So I'm giving you 15 seconds. Please read this question. I specifically mentioned this 3 times about, so you can answer this question clearly. Let me read the question to you. The question is, let A be the infinite set, sorry, A be the finite set containing n distinct element, okay? The number of relations that can be defined on A. That means relation from A to A. We don't have a we don't have a second set. We are relating from A to A. That means, first let me tell you, A cross A will have how many elements? They are told n of A is n. Then what is n of A cross A? N into n, which is n square. So if it is m into n, I said the number of relations will be 2 power mn. But right now it is the same set and m is equal to n. That means how many relations are possible? That is 2 power n square. Right? Where is that option? 2 power n square, where is it? Option A, no. That is 2 power n. Option B, no. Option D, no. That's the right answer, which is option C. Hope this is clear. Yes. So let us go to the next question. Yes. Let me rewrite the question to you if it is not clearly visible. It says R is a relation such that x comma y is the ordered pair in the relation where x plus 2y is equal to 8. It's not a multiple choice question. Okay. This relation is on natural numbers only. Okay, write the range. So what is the range? The range is set of all the second elements of the ordered pairs, right? Yes. Just give me 10 seconds. There is some error in the lighting. Just hold on. Let me check this. Yes, now this must be perfect. Right. Okay. Yes, so what I was talking about is this question. The relation is defined as set of all ordered pairs of x and y such that x plus 2y is equal to 8. Okay, and I want the range. As I want the range, I'll rewrite this question for y. Okay, so be smart. Let's be smart enough so that I don't have to waste my time in rearranging this question unnecessarily. What I want is a range, so I want y only. So let me rearrange this like this: 8 minus x divided by 2. Right? And what they said, it has to be natural number. As it has to be natural number, can x be any odd number? Think about it. Please pay attention to what I'm saying. Can x be odd number? X can be odd number, but when x is odd number here, y will not be a natural number because it will come in decimal. So I know x is only going to take even values. So can I take 0? Not possible, because n, that is natural number. So our first element I have to start with is x is equal to 2. If x is 2, what is y? When x is 2, what is y? 8 minus 2, 6, by 2, 3. Right? When x is next even number only, I will not waste my time in taking odd number anymore. So y will be how much? 8 minus 4, which is 4. 4 by 2 is 2. Next number 6. What will happen to this? Y will become 1. Can I go beyond this? Can I take x is equal to 8? Please tell me. Can I take x is equal to 8? The beauty about the online classes, I have the liberty to extend this so that you can sit, watch, or you can check the recorded videos and even pause and then check what am I saying repeatedly, right? So we can make use of it. Just to mention, so I have all the freedom to explain this repeatedly because we are not running out of time. We don't have to finish the syllabus on time. We don't have a fixed timing, right? So still, as the exam is approaching, we have kept the 2 hours. You can always check these videos again and again once it is uploaded. Right now, yeah. So that's why I could even stop and ask you again, right? Yes. So now my question is, can x be 8? It's not possible, because if x is 8, what will happen? It will become 0. Y will become 0. Not happening. So these are the only elements which y can take. And that is a second set or second element in the ordered pair. So what is our range set? Our range set is 1, 2, and 3. Shall we verify? As it is not a multiple choice question, shall we verify our answer with the answer given here? Let's see. See, I can show you that exactly what I got. The exact answer I'm getting. The range of this is 1, 2, and 3. Right? Yes. So let's go for the next one. So now we are done with the basics of relations. I think after this, you should not have any doubt in the relation. What is relation? The types of relations we are going to discuss right now. I'm only talking about basic part of relation. What is a relation? And if there is a definition given, you should be able to write the relation. Okay? Yes, we are done with all these questions. Now let's move on to function. Okay, what is function? This is new. We did not discuss much about this in the 11th standard. So what is function? A function is also a relation. So remember this word. Function is also a relation. So what do you mean by this? This is a special type of relation where we have a rule. What is a rule? Please read this. A relation f of x, a relation f of x from set A to set B is said to be a function if set B only contains one image for each element of A. Okay, so let me give an example by using a mapping method. That is, see, I have two relations here, and one of them is a function, one of them is not. So I want you to identify the difference. Okay, I want you to identify the difference. See here. I will give you one more example on this side. Out of the three, there's only one which is a function, and the other two are just mere relations. Okay, you have to guess. First, let me map them first. Same elements. I'm not going to change the elements because it has nothing to do with the element. It's about the way we map, right? Okay. So all this is A, B, this is A, this is B, this is A, this is B. Now my question here is, what are the differences you see here? And also please read this one more time and try to observe that same relation what we are talking about are we applied here. Out of these three examples, let it be example 1, example 2 and example 3. Out of these three examples, which one do you think is a function? All of them are relation, no doubt in that, because if there is any connection, if there is no connection also we say they have a relation. So right now, which of them is a function? Can anyone tell me? Shweta, Nikhil, anyone else? Ashish, can you answer? Which of them is a relation? See, I am telling B in the set B only contains one image for each element of A. So let us talk about this particular element 1. What is the image of 1 here? 1 comma A and 1 comma B, right? So this is not a relation, and this is a relation, but it's not a function because 1 is connected to two different elements. So it clearly says every element should have only one image. Here you might see 3 has only one image, 4 has only one image, but 1 has how many image? Only one image. 2 has no image. That is also not a function. So 1 is not a function, 2 is not a function. Then must be obviously, I told one of them is a function, third one is definitely a function. So what are the images of 1? 1's image is A, 2's image is C, 3's image is B, and 4's image is D. Yes, this is a function. Is it not a relation? As all of them are relation, this is also a relation. But what is very clear is not all the relations are functions. So, but the vice versa is true. What is that? Every function is a relation. So initially we understood a relation is what? A subset of A cross B. Now what is a function? Function is a subset of relation. So remember this, a function is coming from relation and relation is coming from product of two sets, right? Is this clear? So there can be one more doubt. I'll explain. I'll give another example to show which one can also another possibility of a function. So let me erase this part. I know this is not a function, right? So we don't want that. I will tell you another way there can be a possibility to clear your doubt. Check this. Yes. Please pay attention to this class. You don't have to even check these concepts again if you pay attention clearly. I'm telling you, 100%. You don't have to attend these classes one more time, or you don't have to go through anything if you pay attention to this class. So please make sure you attend this, and if you definitely feel useful, you can also tell to your friends to attend these classes. If they have missed, you can ask them to check the recorded sessions. It will be useful for everybody, right? So obviously we have to grow together. You can tell your friends to even attend these classes, right? So they'll be very happy, and it is available for free of cost. So you don't have to, you're not making them do anything. Just they have to put an effort in observing these videos, right? Yes. See here. I'm going to have some elements here. Now my question is it a function? Is it a function? Can anyone tell me, is it a function? So as you learned already, we are revising. If we can make it out clearly, it is a function. Yes, this is a function. Here 2 has how many image? Only one image. 3 has how many image? Only one image. 0 might have 2 pre-image. That is not a problem for us. Okay. So just to break the ice, I'm telling you this is still a function because every element in A must have only one image in B. Must have only one image. So every element, that means what? Every single element here definitely have one image. So don't think about these elements having more than one pre-image. That is not a problem. So again, one more example I'll tell you. So what if there are three elements here and there's only one element? And what if they're all related to this? It is still a function because every element in A has exactly one image. The direction is very important. Relation from A to B is a function if every element in A has exactly one image in B. Am I clear? Hope this helps. If this is clear to you, we can understand what is domain of this function. And domain is exactly same as relations we discussed, right? So what is the domain of this function? Can you tell me? The domain of this particular function, all the first elements we have, right? 2, 3, 4, and 5, right? What is the range? The range is 0, 2, and 3. I'm talking about this particular example. Okay, this is the range, this is the domain. I have one more word here, codomain. What is codomain? Codomain is the second set completely. Okay, what is codomain? In this case, the second set completely. So range A must be what then? Range must be a subset of codomain. Okay, what is codomain now? The codomain is nothing but 0, 2, 3 as well as 4. You can also make a note of all this or take a screenshot and write down note later, okay? Because these are completely, this can be considered as a revision notes for you, okay? You don't have to go through the entire topic. If you want to understand and remember the points here, you can write down all these things, okay? Whenever, however you are convenient, you can write down during the class itself, or maybe you can take a screenshot and write the points later, right? Yes. Assuming that you have taken a screenshot or you have written it down, I'm erasing all of them. Okay. So as you know what is function now clearly, can you answer this question? Can you check this example? It's not a question, but check this example. What is told here is y is equal to 2x plus 5, which is a linear equation, is a function. Because for every value of x you put, you get only one value, y, right? So y is equal to 2x plus 5. Any value of x you can give input, y will give only one value. This y is 5. If x is equal to 1, y is equal to 7. That's why it's a function. And after function, we discuss about graphs. Okay, so if you plot a graph of this, it's a line. That's why it's a linear function. Okay, so just to add on to the importance of this question, I'm telling you this graph of this function is a straight line. Okay, whereas y square is equal to x. So y square is equal to x. If I want to find this value of y, I might have to take two values, that is square root of this, right? So if I want to take y, it's plus or minus square root of x. That means plus root x and minus root x, both will be the answer. That means y can take two values for the same values of x. For example, what if x is equal to 4? If x is equal to 4, y square is equal to 4. So what is y? Plus or minus square root of 4, which is plus or minus 2. That means y can have two values. Suppose if you want to show that in the mapping, what will happen is, specifically for this particular function, x will be always a perfect square. We can say 0, 4, 9, maybe it goes on. Whereas here we'll have 0 plus, this is x. Let me erase this. The first one is x. X can take only the square values, right? And then this is set of all x, which is our domain, and our y can take 0 plus 2. Even 1 is missing here. I can put 1 plus 1 minus 1 plus 2 minus 2. If I do the mapping, you see for 1 we'll have two images. For 4 we'll have again two images. This is not a function. That's what is being explained in this example. Okay. So hence second one is not a function and first one is a function. Hope this is clear to you, right? Okay. Read this question. The question is visible. Should I zoom it out or zoom it in? You can tell me. I think it's better. I can zoom it in now a little bit. Can you see the question? Every relation is a function and every function is a relation. Then which is the correct for given statement? Every relation is a function. I kept on repeating these words, right? What is it? Every function is a relation, but not every relation is a function. So tell me now, is it true or false? Can't say anything. That's the most diplomatic answer. You don't want to take a side. You can say, I can't say anything, but you can't do that here. You have to give the right answer. So you can't say anything is not going to be the one you can safely choose. None of this, no. It's either true or false. Tell me what is the answer. See, this part is correct. Every function is a relation, but this part is not correct. Every relation is not a function. That means the answer is false. Every relation is not a function. So what is my answer? Answer is option B, false. Is it clear? Yes, the answer is option B, false. Let's go to the next question. Question number 2. There is a special function given here. If you can understand this, we have to find the range of this function. Okay. What is the range of this function? They are not told and what set they are defining this function, but let's see what is the approach for this question. Let me write it here. F of x is equal to mod of x minus 1. That's absolute value divided by x minus 1. And what is the range of this function? So one thing is very clear. As it is modulus in the numerator, okay, so can this become negative? The numerator cannot become negative. So what about the denominator? So denominator can be negative, right? So let us say x cannot take 1 for sure. Yes or no? Why x cannot take 1? If x takes 1, what will happen? This expression becomes 0 by 0, which is not defined. We don't discuss unreal or imaginary numbers in our syllabus. Okay, so we don't have to get to that. So x cannot be equal to 1. So this will never become 0 as well. What if x is equal to 2 then? If x is equal to 2, what I get is f of x will be 1. Okay. If x is equal to minus 2, f of x will become minus 1. Right? So whatever the value you put in the numerator, so let me take x is equal to 3. Then f of x will become 1. If x is equal to minus 3, f of x will become what? Minus 1 again. That means as the numerator and denominator have the same expression, but only the numerator is positive always, we will get plus 1 as well as minus 1. So that means what is our range? Whatever you put, whether you put an integer, whether you put any rational number, irrational number, whatever you put, except unreal numbers or not defined formats, we always get minus 1 and plus 1. So the range of this function is simply minus 1 and plus 1. It's a very interesting example, right? So whatever you put, the numerator and denominator is going to be same, but only thing is it might take positive value, it can also take negative value. That's why the range of this function is only 2 values it can take, which is minus 1 and plus 1. Right? A very interesting example, isn't it? Let's go for the next one. What is it? The next question is here. Okay. As we are familiar with the trigonometry, a little bit of trigonometry basic is enough for us to understand this question and answer this question. So our function is defined like this. Look at this. Our function is defined like this, which is 1 divided by, let me change this size, 2 minus cos x. This is our function, where x belongs to real numbers. Okay. For all x, this is how we read, right? For all x belongs to real numbers. Then find the range of this function. So let us take this as y. I need to know what are the values y can take. Okay. So the values y can take, it depends upon what x can take, right? What cos x can take. What are the values cos x can take? So the highest value cos x can take is what? +1, and the lowest value cos x can take is what? -1. Yes or no? We know the values of cos function. The range of the cos function is what? -1 to +1. So if you want to make it maximum, what will you do? You will put the lowest possible value here. So if you put the lowest possible value here, what will happen is, that is the lowest possible value here is, see, very simple logic I'm going to use. If you want the maximum value of this, the denominator has to be minimum. If the denominator has to be minimum, what we are subtracting should be the highest. Am I right? So what is the highest value cos x can take is +1. If I put 1 here, this will be 2 minus 1. So this maximum value will be what? So this is 1, right? So what is the minimum value it can take? Simple opposite logic. So we can take 2 minus of -1. So what will you take? 1/3. Okay. So that means my function minimum value is 1/3. The maximum value is 1. So the range, see how we can apply this. You can think about real life application of this. Why we are learning? Because we might have to apply this in our real life situations, right? So I can tell you the range of this function is starting from 1/3 to 1. It will never become negative. Okay, it will only be positive, right? This is the range of this function. So, and it is not, I mean, this is not a right way to represent this, because it can take any value from here to here, and we use the interval notations, that is starting from 1/3 plus 1/3 to 1. Any value it can take. Range is from this interval. This range is going to be anything from 1/3 to 1. Okay. Yes. Okay. Read this question. The question is visible. Should I zoom it out or zoom it in? You can tell me. I think it's better. I can zoom it in now a little bit. Can you see the question? Every relation is a function and every function is a relation. Then which is the correct for given statement? Every relation is a function. I kept on repeating these words, right? What is it? Every function is a relation, but not every relation is a function. So tell me now, is it true or false? Can't say anything. That's the most diplomatic answer. You don't want to take a side. You can say, I can't say anything, but you can't do that here. You have to give the right answer. So you can't say anything is not going to be the one you can safely choose. None of this, no. It's either true or false. Tell me what is the answer. See, this part is correct. Every function is a relation, but this part is not correct. Every relation is not a function. That means the answer is false. Every relation is not a function. So what is my answer? Answer is option B, false. Is it clear? Yes, the answer is option B, false. Let's go to the next question. Question number 2. There is a special function given here. If you can understand this, we have to find the range of this function. Okay. What is the range of this function? They are not told on what set they are defining this function, but let's see what is the approach for this question. Let me write it here. F of x is equal to mod of x minus 1. That's absolute value divided by x minus 1. And what is the range of this function? So one thing is very clear. As it is modulus in the numerator, okay, so can this become negative? The numerator cannot become negative. So what about the denominator? So denominator can be negative, right? So let us say x cannot take 1 for sure. Yes or no? Why x cannot take 1? If x takes 1, what will happen? This expression becomes 0 by 0, which is not defined. We don't discuss unreal or imaginary numbers in our syllabus. Okay, so we don't have to get to that. So x cannot be equal to 1. So this will never become 0 as well. What if x is equal to 2 then? If x is equal to 2, what I get is f of x will be 1. Okay. If x is equal to minus 2, f of x will become minus 1. Right? So whatever the value you put in the numerator, so let me take x is equal to 3. Then f of x will become 1. If x is equal to minus 3, f of x will become what? Minus 1 again. That means as the numerator and denominator have the same expression, but only the numerator is positive always, we will get plus 1 as well as minus 1. So that means what is our range? Whatever you put, whether you put an integer, whether you put any rational number, irrational number, whatever you put, except unreal numbers or not defined formats, we always get minus 1 and plus 1. So the range of this function is simply minus 1 and plus 1. It's a very interesting example, right? So whatever you put, the numerator and denominator is going to be same, but only thing is it might take positive value, it can also take negative value. That's why the range of this function is only two values it can take, which is minus 1 and plus 1. Right? A very interesting example, isn't it? Let's go for the next one. What is it? The next question is here. Okay. As we are familiar with the trigonometry, a little bit of trigonometry basic is enough for us to understand this question and answer this question. So our function is defined like this. Look at this. Our function is defined like this, which is 1 divided by, let me change this size, 2 minus cos x. This is our function, where x belongs to real numbers. Okay, for all x, this is how we read, right? For all x belongs to real numbers. Then find the range of this function. So let us take this as y. I need to know what are the values y can take. Okay, so the values y can take, it depends upon what x can take, right? What cos x can take. What are the values cos x can take? So the highest value cos x can take is what? Plus 1, and the lowest value cos x can take is what? Minus 1. Yes or no? We know the values of cos function. The range of the cos function is what? Minus 1 to plus 1. So if you want to make it maximum, what will you do? You will put the lowest possible value here. So if you put the lowest possible value here, what will happen is, that is the lowest possible value here is, say, very simple logic I'm going to use. If you want the maximum value of this, the denominator has to be minimum. If the denominator has to be minimum, what we are subtracting should be the highest. Am I right? So what is the highest value cos x can take is plus 1. If I put 1 here, this will be 2 minus 1. So this maximum value will be what? So this is 1, right? So what is the minimum value it can take? Simple opposite logic. So we can take 2 minus of minus 1. So what will you take? 1 by 3. Okay. So that means my function minimum value is 1 by 3. The maximum value is 1. So the range, see how we can apply this. You can think about real life application of this. Why we are learning? Because we might have to apply this in our real life situations, right? So I can tell you the range of this function is starting from 1 by 3 to 1. It will never become negative. Okay, it will only be positive, right? This is the range of this function. So, and it is not, I mean, this is not a right way to represent this, because it can take any value from here to here, and we use the interval notations, that is starting from 1 by 3 plus 1 by 3 to 1. Any value it can take. Range is from this interval. This range is going to be anything from 1 by 3 to 1. Okay. Yes.